Hi everybody, welcome back to our YouTube channel. In today's video, I am going to solve today's Leetcode problem. Today's Leetcode problem is 402 remove k digit. So first of all, we will understand the problem statement, and after that we will see the approach of solving this problem. So see, in the problem statement, we have given a string num representing the non-negative integer, okay, and we have also an integer k. So basically we have to return the smallest possible integer after removing k digit from the nums. So let's try to see the example number one. So this is example number one, and we have given a string num that consists of this digit, and we have given k is equal to 3. So in the problem statement, we have to remove exactly k digit from this num such that we get the smaller number. Okay, we get a smaller number. So see, if I remove these things from the num string, that is 432, if I remove 432 in the num string, then we will get the 1219, that is the smallest among all the nums. So see, basically there are so many choices of deleting 3 digit from the num, but we have to delete that element which gives the final output is the smallest. Okay, so if I consider these cases, then here the k is equal to 1. So if I remove this digit, then we get the final answer is equal to 200, that is the smallest among all the possible deletion. So if I see these cases, then we have to see k is equal to 2. It means that num's length is equal to num's length, that is 2, is equal to k. So in that cases we have to return 0 because there are nothing possible after deleting all the elements from the nums. So let's try to understand this problem statement in better way in the whiteboard. Okay, so see, if we have given a num, let's say take example, if nums consist of 1 4 3 7 2 9, okay, and it is also given that k is equal to 2. Okay, so if k is 2 is given, then which digit I will choose from the num such that we have to delete only 2 digit, and we have to choose the 2 digit from the nums string such that we will get the minimum number. So if I choose the digit that is 4, and also if I choose the 7, and after we delete 4 and 7 from the nums string, then our nums will be 1329, that is the smallest num after deleting any other digit. Suppose there are so many possibility of deleting that element. Suppose this is our num string, and if I delete these two elements, then we get this much as the final output, but this is the greater than these things. And we have to delete in such a way that we get the final output is the smallest among all possible output. So suppose if I delete this one and this one, so our output will be 1729, that is greater than these things. So we have to choose in such a way that we get the output is the smallest one. Suppose this is the example, and if the k is given to 3, then if I delete this 3 element, then we get the number that is 1 to 9, which is the smallest among all possible deletion from the nums string. So we have to choose how we will decide which element should be deleted. So let's understand the intuition behind the approach of this problem. Okay, so see, suppose we have given some number, that is, let's consider some number that is 2543, and we have to we have to choose this number and we have to form the smallest number. Then our selection of number, see the all possible number that we can generate from these 4 digit is factorial 4. But the problem statement says that we have to choose in such a way that we get the smallest number. So I can choose the two element that is a smaller among all the four, and after that 3, after that 4 and 5. So this is the smallest possible among all permutation. So how we will get the smallest? So we keep increasing the number, because the element which are at this index has higher priority. Then if the higher priority element is a smaller, then all the element we will get the smaller. Suppose if I put here 3, then 2, then the higher priority contain 3, that is not the minimum among all other elements, so we get the greater element than this element. So see, if we have given something that like 282 and we have given k is equal to 1, so see these things look like, if I draw this thing, then these things occur that thing. See, suppose this is the 2 and this is our 8 and this is 2. Okay, so see we have to delete in such a way that we are able to generate at least such a way that we are able to generate a number that is nearby increasing, not exactly increasing but nearby increasing. So that see, in these cases we get minimum when we are arranged in such a way that the number is in increasing order. But in these cases we are generate the number such, we can generate the element such a way that we get a number that is nearly increasing to that number. So if I consider these cases, then we get a deep after this 8. Okay, so whenever we get the first deep after traversing from left to right, then we have to remove that deep. So if I remove that deep, then our number will be, that is 2 2. This is the this is nearby increasing, because if I delete this 2, then we get 2 8. That is also increasing, but we have to delete in such a way that we are just like nearby increasing. So in these cases we get the output is equal to 2 2. Okay, so if I considered some other cases, see, if I considered some other cases, like take some example like 3 7 2 1 8 1. Okay, so this is our example. So see, if I consider this is 3 and this is 7, and see this is 2, this is 1, and again height, this is 8. Okay, and again this is 1. Okay, this is our string array. Okay, so see what happens. See, we have traversed from left to right. Okay, so whenever we get the, see, suppose if in this question we have given k is equal to 1, then what element we will delete first? Okay, so if k is equal to 1, then our answer will be, that is 3 2 1 8 1. Okay, this is our answer. So see, our maximum element among this string will be 8, but we are not deleting the 8, we are deleting the 7. Why we are deleting the 7? Because 7 has greater priority, or you may say that 7 has the greater priority than the 8, because 7 impacted so much in this number than the 8. So we have to delete the 7, not the 8. So see, we have to delete that number in which we get a dip, first dip. So see, this is 7 and this is 8. Okay, so whenever we get the first dip is just like whenever we get number after increasing, it means that this is a dip. So we have to remove that div. If I remove that div, then our if I remove that div, then our graph look like this case. Okay, and see, if we have k is equal to 2, then see, this is also a div. Then whenever we get any div, then remove that div. So we have to remove that things. So now our nums look like this thing. Okay, so if in these cases, if we have given k is equal to 2, then we have to delete these two elements, and we have the output is equal to 2181. So this is our approach, that whenever we get any div, then we have to remove that div, because that div impact a lot than the any other higher div, because we traverse from left to right, and left digit had more significant than the right digit. So let's try to see another approach and try run our algorithm. That how, see, there are two cases. See, suppose one case is contain the 0, or another case is not contain 0. So let's that cases as well. See, 1 2 3 0 9 8 7. So if suppose we have given k is equal to 2, we have to delete which element? We have to delete this element, that is 2 3. To our final array will be this thing, that is the smallest among all possible thing. So in these cases, if it is given that k is equal to 3, then what happens? So if k is equal to 3 is given, then we have to delete these things, and we get the final output is 987. Because see, 0 has no significance here, because it is the most significant digit. So in the most significant digit, 0 has no any significance. So I hope you understand with the what happens if we include the 0 in the string or not. So let's try to dry run the approach in some big examples. So see, if the string will be 1 4 3 0 1 6 and 2 0. Okay, this is our string. So for this we take a stack data structure that contain that contain a more increasing stack. It means that whenever we get a div, it means that we have to remove that div. So first we push the first element in the stack. Okay, and after that we start iteration from the one index. Then whenever we get a element greater than the top element, then that element will be pushed in the stack, because we wanted the element that is in nearly increasing, not exactly increasing but nearly increasing. But whenever we get a div, so suppose we move to one position, that is this index, that is 1 2 3 4 5 6 7, that is 0 based indexing. Okay, so what happens? See, if I reach the 3 index, then we get a div. See how this is 1 and this is 4 and this is 3. Okay, so we get a div. Whenever we get a div, then remove that div. So whenever we get array of I that is greater than st dot top, top, then we have to remove that div. So we have to remove this div, and after that we push the 3 element. Okay, again we move forward, that is at 0 index. So now our array will be look like 1 and 3. So 1 and this is 3, and again we get a 0. This is also a div. Whenever we get a div, then remove that things. So remove these things, remove till we are not getting any div. So after removing this thing, then our array will be 1 and this is 0. So this is again a div. Then we have to remove this thing also. So we have to remove this thing, and see, after these things we get 0. If I put the 0 in the stack, then there are no any significance of 0, because if the 0 is in the most significant bit, then 0 has no significance. So when the stack is empty and the array element is 0, then in that cases we exclude the pushing statement in the stack. So we move forward. So when we move forward and see stack is empty, then push 1 it in the stack, and after that see again move forward, we see 6, this is greater than top, then there are no any div, so push it in the stack, and after that we move forward, that is 2. Whenever we are 2, then see first we are at 1, then we are 6, again we are 2, so we get a div. And also in these cases we are given k is equal to 4, that is the number of element we are able to remove. So whenever we remove the div, we also decrease the k value. So in the first step we remove this 4, then we decrease the k value as well, that is 3, and if I remove this 3 element, then we also decrease this 2 element is equal to, when I remove this thing, then this will become 1. So see, we are at this index, that is 2, so we get a div. Whenever we get a div, first whenever we get a div and also k is greater than 0 and also stack is not empty, then what happens, we have to remove that div, then we have to remove that div, and we remove till we get the div. After removing this div, then our element our number will be 1 2, so there are no any other div, and also k is become 0. So if there are no div, then push it in the stack data structure, and after that what happens, we are come here and see this is also a div, because see 1 2 and then 0, this is also a div, but the problem is that here k is equal to 0, so we are not able to remove this div, because we have deleted all the greater priority elements from the nums from this string, so we are not able to remove this div, so we are pushing it in the stack data structure, and at last whatever the element is in the stack, that is 1 2 0, we have to pop that element one by one, this is 2 1, and after that we have to reverse that thing, and after that we return it in the answer. Okay, so this is our logic behind solving this problem. So hope you all understand this problem as well as algorithm. So let's try to summarize this approach. So basically in this approach, see our array will be 1430 1430 430 1430 1620. Okay, 1620. So our basic idea behind this algo is, first take a stack data structure and push the first element in the stack. Okay, and whenever we get a div, then we remove the div element. Div element is which element? When we get a of I is greater than st dot top, it means that we get a div, then we pop the top element till k is greater than 0. K is what number of element we are able to remove from this string. Okay, so we do that things again and again, and after that whatever the element stored it in the stack data structure, then we remove that character and we return it in the answer. So let's try to see the code for better understanding. So this is the code. This is our code. So in the code, what I will do, first take a string, that is result, that we are going to return at last. Okay, and take the size of the nums, a string. Okay, so this is our side. And see, if k is greater equal to n, suppose see in these cases, that is n is also 2 and k is also 2, in that cases we have to return the 0, that are we have to return the 0. And after that take a stack. In a stack we have to store all the element that are in increasing order, that is monotonic stack. So we iterate from the left to right. Okay, the first we push the first element in the stack, that is 1 will be pushed in the stack, and after that we iterate from 1 to n. So see, we have, whenever we get a div, so the condition of div is the top element is greater than nums, and also k is greater than 0 because this is k, and also as a stack not empty, then we have to pop that deep and reduce the k minus minus, because we are able to remove one element, so we reduce the k value. And suppose see, and also we see, whenever we hit at any condition in which nums is 0 and also the nums I is 0 and also stack is empty, then there are no any significance of 0, then in that cases we are not going to push that 0 in the stack, and if not, then we push it in the stack. And after that we do this. Suppose we are the element 1 2 3 and k is equal to 3, then in these cases we are not going to find any div. So whatever the element we are getting, push it in the stack, then in that cases k is greater than 0 and stack is not empty, so we have to remove from top. So after that we are doing this step, and whenever we see the stack size is 0, suppose the element is 1 2 3 and k is also 3, so when the k is 3, then we remove these things also, so the size is equal to 0. So size is equal to 0, then whenever we hit the size is equal to 0, so return 0, because there are no any possibility of any number. But if size is not 0, then add every character in the result string, and after that reverse the result string and return the reverse string. So this is our code, and I hope you all understand the algorithm as well as code part of this problem. So let's try to submit this code to see. Yeah, it will be correct for these test cases, and if you try to submit for all the test cases, then you will get the correct result. So this is our code. So thank you for watching the video. See you in the next video.